Look around your home for a second. Maybe there's a barbecue sitting outside. Maybe there's a fireplace that only gets used a few weeks each year. Maybe you've watched glowing charcoal slowly turn white before someone placed food on the grill. You probably never gave those black pieces a second thought. They're just fuel, cheap, ordinary, replaceable. But here's the remarkable part. Those black pieces of charcoal changed human history more than almost any invention you can think of. Without them, there would have been no Bronze Age, no Iron Age, no steel, no Industrial Revolution, and perhaps no modern civilization at all. It's always fascinating seeing how many different parts of the world are uncovering these forgotten stories together. Where are you watching from today? The strange thing is, your ancestors never set out to invent charcoal. They stumbled across it. And like so many of humanity's greatest discoveries, everything began with a simple question. Why does this burn differently? To answer that, we need to travel back much further than the first cities, further than farming, further than writing, almost 1 million years into the past. Imagine you're standing outside a cave in what is now South Africa. The sun has disappeared behind the horizon. The air is getting colder. The sounds around you are changing. Birds have fallen silent. Hyenas begin calling somewhere across the valley. Every instinct tells you to find shelter, because for almost every animal on Earth, night belongs to the predators. But your ancestors had discovered something extraordinary: fire. Not just fire started by lightning, fire they could keep alive. For decades, archaeologists argued over exactly when humans first learned to control it. Some ancient campsites contained burned bones, others contained patches of ash. But critics always ask the same question. How do we know those fires weren't started naturally? It was a fair question. Then, in 2012, something changed. Archaeologist Francesco Berna and his colleagues published a remarkable study in the Proceedings of the National Academy of Sciences. Working deep inside Wonderwerk Cave, they examined microscopic layers of burned bone and plant ash nearly 1 million years old. The fire wasn't near the cave entrance where a wildfire might have blown inside. It was deep in the living area, exactly where ancient humans had been staying. For many archaeologists, it became some of the strongest evidence yet that our ancestors weren't simply collecting fire from nature anymore. They were controlling it. Think about that for a moment. For the first time in Earth's history, one species had learned to keep daylight alive after sunset. Fire changed everything. It frightened predators, cooked food, provided warmth during cold nights, extended the day by several precious hours. But hidden inside every campfire, something else was happening, something nobody understood for hundreds of thousands of years. Imagine waking before sunrise. The flames are gone. Only gray ash remains. You stir the ashes with a stick. Most of yesterday's fire has disappeared, but buried underneath, you notice several strange black pieces of wood. They're lighter than they should be, dry, almost weightless. If you touch them, your fingers become covered in black dust. Most people probably ignored them. After all, they looked ruined, burned, worthless, until somebody did something wonderfully human. They got curious. What happens if I throw this back into the fire? The answer must have seemed almost magical. Instead of producing thick smoke, the black wood glowed bright orange. Instead of struggling to burn, it burned hotter, longer, cleaner. The wood hadn't been destroyed, it had been transformed. Of course, your ancestors didn't know why. They had never heard the word chemistry. They didn't know what carbon was. They certainly didn't know about pyrolysis. That explanation would arrive much later. I'd love to know, before today, did you think charcoal came before coal, or the other way around? Let me know in the comments. I'm genuinely curious. In 2003, chemical engineers John Antal and Gunnar Grunley published one of the most influential scientific reviews ever written on charcoal production. After studying centuries of traditional charcoal making alongside modern chemistry, they explained what had actually been happening inside those ancient campfires all along. When wood is heated with very little oxygen, it doesn't simply burn away. Water escapes, hydrogen escapes, natural gases escape. What remains is mostly carbon. The black material left behind is charcoal. Modern analyses show that properly produced charcoal contains roughly 80 to 90% carbon, making it burn significantly hotter and more efficiently than ordinary wood. Think about how extraordinary that is. Your ancestors had accidentally discovered chemistry, hundreds of thousands of years before chemistry existed. Nobody understood the science, but they didn't need to. They only needed to notice the result. And humans are remarkably good at noticing useful accidents. History is full of discoveries exactly like this. Bread probably began when wild yeast landed on forgotten dough. Cheese may have begun when milk was stored inside animal stomachs. Pottery may have begun when clay was left too close to a fire. Again and again. Civilization moves forward because someone asks one simple question: what happens if I try that again? Charcoal was almost certainly one of those moments. At first, ancient people probably found it by accident. Whenever a fire burned slowly beneath its own ashes, some of the buried wood received very little oxygen. Instead of becoming ash, it quietly transformed into charcoal. Generation after generation, people noticed those black pieces always seemed to make better fires. Eventually, someone must have wondered, what if we could make this happen on purpose? Nobody knows who that person was. Nobody knows where it first happened. And anyone claiming they do is going beyond the evidence. That's one of the fascinating things about archaeology. Sometimes the most honest answer is, we don't know, but we can make remarkably good inferences. Traditional charcoal makers across Africa, Europe, Asia, and the Americas all discovered nearly the same technique. They stacked wood carefully, covered it with soil, left only tiny openings for air, then allowed the wood to smolder slowly. Too much oxygen, everything became ash. Too little, the fire died. Somehow people separated by oceans discovered almost identical solutions. Not because they shared ideas, because they shared physics. The laws of nature are the same everywhere. But here's where the story becomes even stranger. Charcoal didn't just change fire, it changed human imagination. Imagine entering a cave 36,000 years ago, carrying nothing but a burning torch. The walls around you are blank limestone. Someone reaches into the fire, pulls out a blackened stick, then begins drawing horses, lions, rhinoceroses, animals moving across stone walls with astonishing realism. When explorers rediscovered Chauvet Cave in southern France in 1994, they realized they were looking at one of humanity's oldest art galleries. Then, in 2001, Hélène Valladas and her colleagues published radiocarbon dates in the journal Nature. The black pigment covering many of those magnificent animals wasn't paint. It was charcoal, burned wood. Some of those drawings were nearly 36,000 years old. Later studies, including work published by Émilie Quiles and colleagues in 2016, confirmed many of those early dates, reinforcing Chauvet as one of the oldest known masterpieces ever created by our species. Think about that. The same material that cooked dinner also preserved stories. The same black branch that kept children warm allowed artists to leave messages for people they would never meet, including you. Very few discoveries in history have served both survival and imagination, but charcoal did. And yet, despite learning to make charcoal, despite mastering fire, despite creating hotter flames, your ancestors still hadn't discovered the black fuel that would eventually power steam engines, railways, and factories: coal. Because coal wasn't made by humans. It was made by forests. Forests that died more than 300 million years before the first human being ever walked the earth. Entire ancient worlds had been quietly buried beneath our feet, waiting. The strange part is, humans walked over those black rocks for thousands of generations without realizing what they were. Why? Why discover charcoal long before coal? When coal was everywhere? That answer takes us into one of the greatest geological stories ever told. And it's even stranger than the one we've just uncovered. Before we continue, I'd love to hear your thoughts. What surprised you more? That your ancestors accidentally became chemists? Or that one burned branch eventually became one of humanity's oldest pencils? At this point in the story, your ancestors had already mastered charcoal. They knew it burned hotter than ordinary wood. They cooked with it. They warmed themselves with it. Eventually, they even used it to create some of humanity's oldest works of art. But here's the strange part. The fuel that would one day power the Industrial Revolution, the fuel buried beneath entire mountains, the fuel that could burn for hours, still hadn't been discovered, not because it was hidden, because nobody knew what they were looking at. Think about that for a moment. Imagine walking across the same hillside every year of your life. Your parents walked there, your grandparents walked there, their grandparents walked there. Beneath your feet sits enough coal to power entire cities. And yet, to you, it's just another black rock. The question isn't, why did humans discover coal? The real question is, why did it take us so incredibly long? The answer begins long before humans existed, long before mammoths, long before dinosaurs, long before the first bird ever flew through the sky. To understand coal, we have to travel back more than 300 million years. Picture a world that doesn't look like Earth today. Instead of grass, Towering forests of giant club mosses and tree-sized ferns stretch across enormous swamps. Dragonflies as large as hawks fly between the trees. The air contains far more oxygen than it does today. Life is thriving. Then, something remarkable happens. Trees die. They collapse into swamp water. Normally, dead wood rots away. Bacteria and fungi break it down until almost nothing remains. But these ancient swamps were different. The fallen trees became trapped beneath water where very little oxygen could reach them. Year after year, flood after flood, layer upon layer of mud buried those forests deeper beneath the earth. Pressure increased. Temperatures slowly rose, not over centuries, not over thousands of years, over millions. The wood didn't simply decay, it transformed, first into peat, then lignite, eventually into coal. One of Earth's greatest geological accidents. Today we know this transformation because geologists spent centuries piecing together the evidence. In 1987, paleobotanist William Challoner described coal as one of the planet's greatest archives of ancient forests, preserving ecosystems that disappeared hundreds of millions of years ago. Every lump of coal is, quite literally, compressed prehistoric life. Think about that. The coal sitting inside an old steam engine was once part of a living forest before the first dinosaur had even evolved. You're not burning rock. You're burning sunlight captured by plants hundreds of millions of years ago. That idea almost feels impossible, but it's true. The energy stored inside coal began as sunlight, captured through photosynthesis, locked underground by geology, released by humans. It's one of the longest journeys energy has ever taken. But here's something even stranger. Ancient humans had absolutely no way of knowing any of this. To them, coal didn't look particularly useful. Fresh coal isn't shiny. Many pieces resemble ordinary dark stones. Some are dull, some crumble easily. Some don't even ignite unless they're already extremely hot. Compared with charcoal, coal actually seems disappointing. Imagine you're sitting beside a campfire 50,000 years ago. Would you throw a familiar piece of charcoal into the flames? Or an unfamiliar black rock? The answer seems obvious. Charcoal had already earned people's trust. Coal hadn't. This is one of the most overlooked ideas in technological history. People rarely abandon a solution that already works, especially when survival depends on it. Charcoal was predictable, reliable, portable. Anyone could make it. Coal couldn't compete, at least, not yet. This is why archaeology tells a surprisingly patient story. There is no single moment when one person suddenly invented coal. Instead, different civilizations slowly noticed the same strange phenomenon. Certain black stones burned. One of the earliest written clues comes from ancient China. Historical evidence suggests that coal was being used in some regions more than 2,000 years ago. By the time of the Han Dynasty, people were already exploiting coal deposits for heating and industrial activities in parts of northern China. Not because someone understood geology, simply because generations of observation revealed that certain rocks produced heat. On the other side of the world, the Romans also encountered coal. Archaeologists excavating Roman settlements in Britain have discovered coal fragments inside homes and military sites dating to the 2nd century AD. People living near exposed coal seams had begun collecting it. Not on an industrial scale, just enough for local fires. Again, nobody was searching for coal. They simply noticed that certain black stones behaved differently when placed in a hot fire. History repeats itself. Observation, experiment, discovery, just like charcoal. But here's where the story becomes even more fascinating. Even after humans discovered coal, they still preferred charcoal for thousands of years. That sounds backwards. Wouldn't the better fuel replace the older one? Not necessarily, because charcoal possessed one extraordinary advantage: purity. Ordinary coal contains sulfur and numerous mineral impurities. Those impurities don't matter very much when you're heating a house. They matter enormously when you're making metal. Imagine trying to create a bronze axe or an iron sword. A tiny amount of contamination can ruin the final product. Charcoal, being mostly carbon, burns much cleaner. That's exactly why it became the foundation of early metallurgy. In his landmark book, A History of Metallurgy, archaeometallurgist Ronald Tylecote explained that charcoal dominated ancient metalworking because it could produce exceptionally high temperatures while introducing far fewer impurities than raw coal. Simply put, it made better metal, and better metal changed everything. Around 2010, archaeologist Miljana Radivojevich and her colleagues published remarkable evidence from the site of Belovod in modern-day Serbia. Their research, published in the Journal of Archaeological Science, showed that people were intentionally smelting copper around 5000 BC. That makes Belovode one of the oldest known examples of extractive metallurgy anywhere in the world. But here's the detail most people miss. Those furnaces almost certainly relied on charcoal, not coal, burnt wood. Think about the chain of events. Someone accidentally discovers charcoal. Generations later, people realize it burns hotter. Eventually, it becomes hot enough to transform stone into liquid metal. That single accident quietly launches the Bronze Age. The people operating those furnaces probably had no idea they were changing human history. They simply wanted better tools, better knives, better axes, better lives. History often works like that. Small improvements, enormous consequences. But despite all this, coal was waiting patiently, buried beneath hills, hidden beneath forests, ignoring humanity just as humanity ignored it. It would remain largely overlooked for centuries more, until one problem became impossible to ignore. The world was running out of trees, and when that happened, everything changed. A growing shortage of wood forced humanity to look beneath its feet, why coal suddenly became more valuable than forests, and how one forgotten fuel ignited the Industrial Revolution. Before we continue, here's something I'd genuinely love to know. Which surprised you more? That coal is actually the remains of forests more than 300 million years old. Or that ancient civilizations knew about coal but still chose charcoal instead? Tell me in the comments. Do not forget to hit hype button, because sometimes the biggest revolutions in history begin with something as simple as a piece of burnt wood or a rock everyone else walked past. For thousands of years, nothing changed. Charcoal remained the king of fire. Blacksmiths trusted it. Metalworkers depended on it. Families cooked with it. Kings built armies with weapons forged by it. Coal was still there, buried beneath hills, waiting. The strange part is, humanity wasn't ignoring coal because it was useless. We were ignoring it because we didn't need it. At least, not yet. History doesn't always change because someone invents something new. Sometimes, history changes because the old solution begins to disappear. Imagine standing in England about 500 years ago. The village around you is growing. More houses, more ships, more workshops, more people. Every one of them needs wood. Wood for cooking, wood for heating, wood for building homes, wood for making charcoal. The forests that had seemed endless for generations are beginning to shrink. Trees that took centuries to grow disappear in a matter of hours. At first, nobody panics. People simply walk a little farther to gather firewood, then farther still. Eventually, entire hillsides stand bare. The fuel that had powered civilization for thousands of years is becoming harder to find. And that's when people begin looking somewhere they had almost never looked before, down, beneath their feet. The black rocks that had once seemed ordinary suddenly looked very different. Not because coal had changed, because the world around it had. This is one of the great lessons of history. Resources don't become valuable simply because they exist. They become valuable when something else becomes scarce. Wood was disappearing. Coal suddenly became an opportunity. But there was still one enormous problem. Coal produced thick smoke. It smelled different. It contained sulfur and other impurities. Many people hated using it. In medieval England, burning coal inside cities became so unpopular that historical records describe repeated complaints about the smoke darkening the air. Some rulers even attempted to restrict its use near London. Think about that. The fuel that would eventually power the Industrial Revolution was once considered an unpleasant nuisance. History is full of discoveries that people disliked before they depended on them. But necessity has a remarkable way of changing opinions. As forests continued disappearing, coal slowly became impossible to ignore. Then, another discovery changed everything. Steam. Most people think the steam engine created the Industrial Revolution. That's only half the story. A steam engine without fuel is just an expensive piece of metal. Coal became the fuel that allowed those engines to work day after day without consuming entire forests. Suddenly, factories no longer needed to stand beside rivers. Mines could dig deeper. Ships crossed oceans more reliably. Railways connected entire countries. One fuel transformed into movement. Movement transformed into industry. Industry transformed the world. It happened so quickly that people living through it could barely believe what they were seeing. Entire cities appeared where fields had stood only decades before. Machines replaced muscles. Smoke replaced silence. For the first time in history, human civilization was powered not by today's sunlight, but by sunlight stored hundreds of millions of years ago. Think about that. Every steam locomotive, every factory chimney, every early power station was burning ancient forests, not metaphorically, literally. That black rock inside the furnace once grew beneath prehistoric skies long before mammals existed. The energy-lifting trains over mountains had begun as sunlight shining onto leaves during the Carboniferous period. Few stories in science are more astonishing than that. In his book, The 2-Mile Time Machine, geologist Richard Alley described coal as ancient solar energy preserved beneath the earth over immense spans of geological time. The Industrial Revolution wasn't simply powered by rock, it was powered by deep time. And yet, even during this extraordinary transformation, charcoal refused to disappear. It still made better fuel for many blacksmiths. It still produced cleaner metal. Even today, many traditional metalworkers continue using charcoal because it burns hotter and introduces fewer impurities than untreated coal. Sometimes, the oldest technology remains the best one. But here's where the story becomes unexpectedly personal. Everything we've talked about today, fire, charcoal, coal, steam engines, factories, electricity, it all began because one human being noticed something strange inside a dying campfire. Think about how small that moment was. No celebration, no newspaper, no scientist, no king announcing a discovery, just someone poking ashes with a stick, lifting a strange black piece of wood, and deciding, almost absent-mindedly, to throw it back into the fire. History changed because somebody became curious. That pattern appears again and again throughout human history. Someone notices, someone experiments, someone asks, what happens if civilization advances one question at a time? There's another remarkable pattern hiding inside this story. Coal and charcoal look almost identical. Even today, many people confuse them. One was made by people, the other was made by nature. One forms in hours, the other forms across hundreds of millions of years. One helped humans master fire, the other helped humans master industry. They're connected, yet completely different. That's one of history's favorite tricks. The things that look most alike often tell entirely different stories. Perhaps the biggest surprise isn't that humans discovered charcoal, or even that we eventually discovered coal. The biggest surprise is that neither discovery happened because people were searching for them. Both began with observation, curiosity, patience, the willingness to notice something everyone else ignored. Archaeology teaches this lesson over and over again. The greatest discoveries are rarely dramatic in the moment. They only become extraordinary when viewed across centuries. That's why history feels so different looking backward. We know how the story ends. Your ancestors didn't. When someone first picked up charcoal, they couldn't imagine steel bridges. When someone first burned coal, they couldn't imagine railways. When engineers built the first steam engines, they couldn't imagine electricity powering billions of homes. History is always larger than the people living it. And perhaps that's comforting, because it reminds us that ordinary people often create extraordinary futures without ever realizing it. The next time you see charcoal glowing inside a barbecue, or watch an old steam locomotive burning coal, you'll be looking at two chapters of the same story. One began around a prehistoric campfire nearly 1 million years ago. The other transformed the modern world. Together, they changed human civilization forever. But here's one final thought. For hundreds of thousands of years, your ancestors looked into fires almost every single night. They told stories, cooked meals, stayed warm, protected their families. They probably never imagined that hidden inside those flames was a discovery that would eventually send people across oceans, raise cities toward the sky, and place human beings on the moon. Not because fire alone achieved those things, but because fire taught us something far more important: to pay attention, to observe, to experiment, to ask questions. That might be humanity's greatest invention, not charcoal, not coal, curiosity itself. So today we've uncovered 4 remarkable discoveries. First, charcoal wasn't invented, it was accidentally discovered inside ancient campfires. Second, coal wasn't created by humans at all. It was formed from forests that lived more than 300 million years before our species existed. Third, ancient civilizations knew about coal, but continued choosing charcoal because for thousands of years it was simply the better fuel for making metal. And finally, the Industrial Revolution didn't begin because someone suddenly found coal. It began because humanity reached a moment when forests alone could no longer support a growing civilization. Sometimes, the biggest revolutions begin not with a new discovery, but with an old solution reaching its limits. Before you go, I'd love to ask you one last question. Which discovery surprised you the most? That charcoal accidentally became the foundation of metallurgy? That coal is actually compressed prehistoric forests? Or that civilization was transformed because one curious person noticed a strange black piece of wood inside a dying fire? Tell me in the comments. I read every one of them, and many of your ideas become future videos. If you enjoy exploring the forgotten discoveries that shaped humanity, consider subscribing to Forgotten Ancestors. Every week, we uncover another ordinary object, another everyday habit, or another ancient mystery. That completely changes the way we see ourselves.